Hi there, we're going to talk about gases and mixtures of gases. So we talked about Mount Everest and Denver before. Remember, when we go to those locations, we have less air pressure, and so within that mixture of air, there's less oxygen. So people have to their own oxygen when they go up to scale Mount Everest, or they are going to feel a little bit when you go up in Colorado. When you're high up, you're going to feel it when you're trying to exercise. There's less oxygen in that mixture of gases. So let's talk about mixtures in this section. So the total pressure of the air that you're feeling is a mixture, that total pressure is a mixture of partial pressures of the gases that are in air. You know that air has a lot of different gases in it. Mostly it's nitrogen, and then about 21% oxygen, and then there's other things in there as well. But generally it's nitrogen, oxygen, and a few little tiny bits of other things. But the total pressure you're feeling around you from the air is a total pressure, and it's based on all the pressures of all the individual gases combined. So partial pressure is each pressure for each one. And then total pressure, remember this is the pressure at sea level is the atmospheric pressure. It's a combination of all these pressures. So you just add them up. The math is easy. In these problems we're either adding or subtracting. And the total is the total of all the pressures in the mixture. So it's not hard. The total pressure is just the sum, just adding all the pressures of everything that's part of the gas. It's not hard. Don't make this problem hard. It's very, very easy. Just add up all the pressures, you're going to get the total. Okay, so that's called partial pressures. Dalton's law of partial pressures. So it's not hard. So it just says that if you have a total pressure, it's the combination of all the partial pressures, all the individual pressures of the gases. So it's very easy. So if we combine A gas, B gas, C gas together, when we add them all together, it's going to make the total pressure. Very easy. 100 plus 250 plus 200 makes 550. So this is the total pressure, and these are individual partial pressures. Add up all the partial, get the total. Very easy. So when we're trying to survive, we need to have this much oxygen in the mixture, that much pressure of oxygen in the mixture for us to survive. So air contains all these things, like we said. If the pressure of oxygen is this, if the pressure of, what is the pressure of this when we know the total pressure? Okay, and then they gave us nitrogen, carbon dioxide, and other gases. So we have the total. We have the total as this, and then we have all the individuals except for oxygen, and we're just going to subtract to get that last one. So we have nitrogen, oxygen, CO2, other gases. We have a total. We don't know oxygen. So we're going to put it into the equation. And the only one we do not know is this guy. So we're going to add these up together, subtract it from the total, and we'll get the oxygen. Very easy. Okay. So they just rearranged the equation so they get oxygen by itself. Total minus the other guys gives you pressure for oxygen is 21.22. So in this one we're going to use the sig fig rules for adding and subtracting, so remember that. So we have 2 places after the decimal, 3 places after the decimal, 2 places after the decimal, so our answer has to have 2 places after the decimal point. Okay, so you can try this one, see how you do. And then there's another law called Graham's law. How does the molar mass of a gas affect how it moves through air? Effuse or diffuse? Diffusion is what molecules want to move from an area of from high pressure to higher concentration to lower concentration. That's why we talked about the skunk a long time ago in several lectures before this. If there's lots of skunk gas juice in the air, that skunk gas, because of entropy, is going to want to move away from that concentrated area to a lower concentrated area, so that's why you smell it far, far away. Diffusion. So bromine, remember I talked about bromine you can go from, iodine's the same way. You can have a solid down here, and then it's going to turn into a gas, and then slowly moving itself outwards. That's diffusing. After a long time, it's going to bounce around until everything is pretty much even. It's diffused from the bottom to the top. Effusion is when you have like a little pinhole in a balloon and the air starts forcing itself out of that little hole. That's effusion. So gases that are really light can diffuse faster and diffuse faster than higher, bigger guys. So small guys can really move faster and move around and move away from each other fast. So Graham's law says that the rate of diffusion of a gas is inversely proportional to the square root of the molar mass of that gas. Okay. So a helium-filled balloon will deflate sooner than an air-filled balloon because helium is a tiny little molecule. Its mass is small, and air is made out of nitrogen. It's bigger, and oxygen. They're bigger. Okay. So the little tiny helium can move around. They have more. If they have the same kinetic energy as the regular air molecules, they can move better. So this is the math. This is the math of this. The rate of atom or molecule A divided by the rate of atom or molecule B is you switch B on top, molar mass, A on bottom, molar mass, take the square root of that, gives you that rate relationship of A to B. So rate of helium compared to nitrogen, take nitrogen's molar mass, helium's molar mass, figure out the math of it, you get 2.7. So helium can go this much faster than nitrogen because of its size. So about 3 times faster. So let's try this quiz. Here's one. So we have partial pressures. And see if you can figure out the oxygen partial pressure, knowing the other things. So pause me. We have a total pressure, and then we have the partial pressure. So see if you can figure out that unknown oxygen partial pressure. So pause me and I'll give you the answer. So that should be 200. 600 plus 200 makes 800 total pressure. Okay, let's try the next one. So try this one, and I'll give you the answer. Pause me when you're ready. So that's what you usually get using this ratio factor. Okay? Alright, Graham's law. Alright, here we go. Alright, so we need molar masses on this one. And they're inversely proportional. Alright, so I hope you enjoyed this. This is, the partial pressure is easy, but then the Graham's law is a little bit more complicated on the math. But the concept, I think, is pretty easy to grasp. So enjoy this one, and I hope you are understanding it pretty well. Alright, I'll talk to you soon. Bye-bye.